Wadup. So in this video, we will see that even being a single-threaded language, how is JavaScript able to perform asynchronous operations? Which just doesn't make sense because you have a um, single unit to operate, and you are able to perform asynchronous operations. Now, before we actually look into how it does, uh, we should be very clear about what it does because, again, this is something which is very confusing. A lot of people who are using JavaScript in their daily lives, they generally will get confused what is happening and how JavaScript plays this trick of performing asynchronous operations even though it is single threaded. So, in simple words, if I tell you that, let's say you have 10 operations and each of those operations are taking 2 seconds. Okay. Let's say one operation is to maybe not just into programming terms. Let's take a real life example. Let's say you have to perform 10 tasks every day, and you guys are you have a team of, let's say, 10 people. For every single person will perform single task. Okay, so someone is supposed to, let's say, do cooking. Someone is supposed to let's say, do reading and then documenting the data. Other is supposed to do some coding and all that. Okay. Now, what you will notice is that depending upon different things, like in some cases, these tasks can be interrelated. Let's say someone is supposed to serve the food. So, after the cooking is done, they can only serve it. Otherwise, they cannot. So that is one case, but we are not considering those. We are just keeping the example as simple as possible. So we have 10 tasks, and assuming that every task takes 30 minutes, there are two ways to perform these tasks. First way is that let's say we will start from the task one. Once that is done, we will move to the task two. Then once that is done, we will move to the task three and so on until the task 10. So this will mean 30 into 10, that is 300 minutes, which is basically 5 hours. So this end, like the person who is waiting for the last task, the result coming from the last person, it will be delayed to a very bigger extent, right? And even if you think practically, if these tasks are independent, then practically what you will be doing is, okay, the day has started, all of us start doing our tasks and get it done. And in that case, the maximum time it will take is just 30 minutes, right? So these 10 people that I'm talking about are basically the threads, okay? And in other languages, multi-threading is supported. Basically, the smallest unit that can be given instructions to perform the task, that is a thread, okay? So in other programming languages like Java and Python, these are supported. So you can use threading libraries, and you can just write threads, join, thread.start, thread.join, and all that, okay? Now JavaScript has a single thread. That means it is just a single person. Okay. Now how can JavaScript, if 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 they are single person, it's a single person language, basically single thread language, be able to perform all these tasks asynchronously. That is, you know, um, uh, it won't wait for the food to, let's say, cook or whatever. It can move on to the next one. So this just confuses. This is the paradoxical situation that JavaScript throws us to. Now you might be thinking, okay, maybe behind the hooks, JavaScript does some magic or some multi-threading thing, and that is true, right? But how exactly it does it, and how this internal thing and everything works, that is what we are going to explore here. Okay, so I hope you got the problem. What is the problem, and how JavaScript, being a single-threaded language, because see, multi-threading is very important. You see all these web applications, you play games and all. Uh, if the multi-threading won't be there, it will give a very bad user experience, because let's say you click the button, then everything just freezes for the moment. Let's say you make an API call to a backend, and then you get the data. Until that point, everything freezes, and it will give you a very bad user experience. Even though if that particular button is, let's say, just rendering a small section of your website, still it will block everything, and that is something we don't want, right? So that is why JavaScript, what it does is it does this thing through these magical terms, which is like JavaScript runtime and the thread pool. Okay. Now let's see what does these things do. So what I'll do is I'll create a function which I'll call sequential function. And before that, let's have it like this. So let's have x equal to 5. We will create a variable. First, we will see it in the global scope because we also want to see how heap memory works, which is part of this JavaScript runtime. It has a call stack that keeps track of all the function calls in which order they are supposed to perform, and then this heap memory, which keeps track of all the variables that are used. Okay, so I'll do console log operation has started. So this is just a sequential program. So let me just rename this. So sequential.js. Then console log operation is started with x equal to x. Then we have mm, x equal to x plus 5. Now console log operation has finished with x equal to this. Okay. Now what JavaScript does is it recognizes what kind of operation is asynchronous, and you understand, right? Anything that is dependent outside of JavaScript, like let's say you make an API call, you are taking a user input, so you don't know how long user will take to put the input, right? So all these kind of operations JavaScript understands. Okay, these are asynchronous operations. And statements like addition, like if you see here, assignment to a variable, logging a particular value, then incrementing the value by addition operator, then again printing the value or logging the value. JavaScript understands, okay, these are the statements that are sequential, and then whatever statements that are what do you say that asynchronous. Okay, and even we have this thing called async await, which we can use to tell JavaScript that what is uh, if a certain statement is asynchronous or synchronous, right? So all of these things JavaScript differentiates between the statements and accordingly operates. And if you see, this is very this is, I would say, one of the biggest I would say plus point for JavaScript, because even if in threading languages, if you write parallel threads, you have to write additional syntax like join, and then like start the thread when they are supposed to start. If you are sharing the variables, you have to take those considerations and all. However, using just async await keyword, it may and promises, callbacks, these are the part of JavaScript, which makes things pretty easy. So, so number one thing is that JavaScript differentiates between asynchronous and synchronous tasks. Okay, this is the role of JavaScript, and let's say it will label task which is synchronous as S and asynchronous as AS. Okay, A. Let's keep it A. Okay. So now moving ahead. So what will happen is if I run this program, sequential continuous. So you can see how it executed. Operation started with x equal to 5. Operation finished with x equal to 10. And if you look into call stack, let's have a debug. Let's run this in a debugger mode. So we will have a breakpoint here. Then we will have a breakpoint here, and that's it. I think that should be good enough. Okay. So if I save this and let me go to debug mode and run and debug with Node.js. So you can see until this point we have just declared this variable, and that's why it is currently undefined. And now if you see the call stack, it is empty. But if I play next, now this time particular console log has been done. So call stack did this and then popped it out. Okay, popped it out meaning the process is complete, so it moved out. Okay, and then if I go here next, then the process goes over. Okay, and of course this is very straightforward, so there is nothing much. But if I tell you in a brief way how it is happening is, so first it will come x equal to 5. So this is the execution that will happen. So this will go into the call stack, and since x is declared here, so let x equal to 5, the statement will come here. It will pop inside the call stack. Okay, now JavaScript, it will check, okay, this guy is a synchronous statement. As I told you, right, it defines this differentiates between synchronous and asynchronous. It will see, okay, this is synchronous statement, so without waiting any further, it will put it into the main thread. It will execute the statement, and since it's an assignment operator, so a variable with x equal to 5 will be added into the heap memory. Okay, so this will be the result of the first statement. Now, the next statement that comes in is that console log statement. Console log, if I just show you. uh, this guy, this one, line number 2. Okay, so this statement again pops into the JavaScript call stack, and JavaScript sees, although this will be all popped together, but I'm just doing it one by one so it is easier to understand. JavaScript sees, okay, this is again an asynchronous statement. It goes to the main thread, and main thread executes it, and then you will get the output in the this console or wherever you are operating. Okay, so this will come out as an output, and then this function will be popped out of call stack, and then it will remove it. Okay, now it goes to the next statement. It does this assignment in the same way. It checks, okay, this is an assignment statement. It will go from here, go to the main thread, assign, change the value of x equal to x plus 5, which is 10 now. So it will update the value and move to the next statement. Now it will go to this console log, again do the same thing, uh, put the call inside the call stack. Call stack will check, okay, this is a synchronous statement. We'll throw it to the main thread. Main thread will execute it. Once the printing is done, then it will move out. And now it sees that everything is done, so it will delete all the heap memory, and that's it. The program is done. Okay, call stack is empty, heap memory is also empty. So this is an example of synchronous statement. Now, if I go and show you a asynchronous statement, so let's have it like this. And let's have because we can use API calls, anything, but let's have set timeout, which is very simple. I would say simpler implementation, because we are not focusing on what kind of asynchronous statements are there. We just want to see how asynchronous statements are handled. So what I am doing is, here I will do x equal to x plus 12. Okay, and then I will log uh, operation has finished with async x equal to x. Now, if you see this, what do you think the output will be? Basically, set timeout, it takes two arguments. One is a function. Here, this is an arrow function. I hope you know what is the syntax. And then it waits for 4000, which is milliseconds, basically 4 seconds. And after 4 seconds, it does this assignment, and then it logs it. Okay. So what do you think output would be? Let's make it more easy. So x equal to x plus 10. So at this point, if you see, this set timeout is kind of a asynchronous operation. Okay, so JavaScript will tag it as asynchronous. Okay, and let's see how this is happening. So let me just clear this out and run this sequential.js, and you can see the program is still running. It's still running, and after some time it gives me 20. Okay, so you will see that what happened is JavaScript did not wait for this entire statement to complete. It directly went to this guy, which is operation finished with x equal to 10. And once after 4000 seconds, it then went to this particular person, right? So this is what uh, is asynchronous programming. As I told you, that JavaScript did not wait to complete it in sequence, even though it is single threaded. Now, how did JavaScript do that is what we will be understanding. Okay, so let me remove the breakpoints and let's see how it is. So I'll just put the breakpoints in console log statements. So if you see, these are the breakpoints, and if I click on run and debug, carefully observe what happens. Okay, so it goes to the statement. It will now console log it. So let me just open the debug console, and let's move next. So it goes to this statement. It comes here, but again, because this is an asynchronous statement, it totally ignores it and moves to the next statement. Okay, and if I play next, then it goes here. Now, since the time of 4 seconds has completed, so it will just console log this, and that's it. That's how program is killed. So this is a high level perspective, but now let's understand how exactly this all is happening, how JavaScript is able to do that. Okay, so let x equal to 5, the same thing will happen. Okay, so let me use the same block. Okay, uh, this pops into the call stack. It sees, okay, it is an asynchronous statement. It executes immediately, so x becomes 5. Initially it will be undefined. X becomes 5, then it moves away. Then after that, it goes to the console log statement. So let me change this to console log. Now this statement pops in. It sees that, okay, this is again synchronous statement. Moves to the main thread. Main thread executes it and then pops it out. Locks the statement and pops it out. Now again it sees this assignment operation. It again checks, okay, this guy is again what do you say that synchronous statement. And I hope you are understanding JavaScript, how it differentiates between synchronous and asynchronous. It basically sees, yeah, like what are the function calls and whatever functions are used, and based on that it will assign it as synchronous or asynchronous. So this comes in, it sees, okay, this is a synchronous statement, goes to the main thread, quick does a quick assignment of 5 plus 5, which is 10, and then pops it out. Now it goes to the set timeout. Now if this this set timeout, JavaScript identifies that, okay, this guy is a asynchronous guy. Okay, so now JavaScript says that, okay, I found this set timeout statement, which is an asynchronous thing, and since this is an asynchronous thing, and because I'm a single threaded guy, I cannot handle this. JavaScript is very clear, in its concept, and it's like, I cannot handle this. So now what it does is, when it sees, okay, this is a asynchronous statement, it takes a subscription of this, like subscription in a way. When this is going to end, it just takes that subscription and says that, okay, if you are running JavaScript in browser, these in browser we have something called web API, and if you are using Node.js environment, they are also known as thread pool. Although these two can be interchanged and referred, not a big deal, but yeah, this is the idea. So what JavaScript does is, okay, can you please help me out with this statement? Can you execute this and complete this statement? And once this is done, I will just listen to your subscription. That is, once you are done, you just tell me, okay, JavaScript, I'm done with this statement, and then I will take up from there onwards. Okay, so that is how JavaScript treats these statements. So what will happen is, it will come here, it will recognize, okay, this is asynchronous. It will ping thread pool. It will say, hey dude, can you just handle this for me? And this guy will, yeah, sure, why not? It will take care of this statement. And meanwhile, it is happening, what JavaScript will do is, it will move on to the next statement, which is this console log. Okay. Now this console log, JavaScript will again see this guy. So if I just copy paste it here, so JavaScript will be like, okay, so we got another synchronous statement. So this I have to handle on my own. So it will take it in the main thread, it will log it, and just complete the execution and pop it out of the call stack. Now after 4 seconds, thread pool will be like, whatever you gave me, whatever statement you gave me, it is done. Timeout is finished. 4 seconds are done. So now you can take control from here. JavaScript will be like, okay, great. So what it will do is, it will move inside this, and then it will see, okay, this is x equal to x plus n. So it will check for this execution. So let me just replace it with here. Sorry, x equal to x plus 10. So JavaScript will look into it. It will say that, okay, this is again a synchronous statement. So I will move it to the main thread. It will execute, and now the x value will become 20. And then after that, it will take this down. I mean, pop it out of the call stack. Now next statement, it will see console log operation has finished. So it will again see, okay, this is also a synchronous statement. So JavaScript will be like, I will handle this guy. And of course, this has been done, so it will be moved out. So now here console log, JavaScript will be like, okay, I will handle this guy again, and it will again console log. And then once this is done, now call stack is empty, JavaScript will end the program. So this is how smartly JavaScript handles this, and the variable will also be destroyed. This is how JavaScript smartly handles the asynchronous operation. So the idea is that JavaScript just doesn't care if it is an asynchronous statement. It pushes it to the whatever runtime it is consuming. In case of browsers, these are called web APIs. Browser supports web APIs, where you can use these thread pools, small thread chunks, and JavaScript says that, hey dude, can you just handle this for me? And then yeah, it can be as many operations as you want, depending upon, of course, the memory of the system and all that. But all these will be pushed to the thread pool, and once they get executed, they will come back to the JavaScript and say that your job is done. Now whatever you want to do after that, you can take control from there. So that's how JavaScript does all this thread pool thing, and all the asynchronous operation. If you see the main thread, JavaScript has only one thread, but JavaScript smartly pushes this thread pool and waits them for getting completed. And once that is done, then JavaScript moves to the next statement. So I hope you understood the concept of thread pool and web API, and how JavaScript, even being a synchronous single-threaded language, is able to perform multi-threading operation. And I think this is a very smart move and approach, because we can use async await promises to to pretty much any kind of asynchronous operation with JavaScript. Let's say you had some more asynchronous operation here, you could have added set timeout, and JavaScript would have looked into inside this function, and then it would have again added the same thing into the thread pool. So yeah, this is how this JavaScript handles this request. And I hope you got a good understanding of now why JavaScript, even though it is a single-threaded language, it can handle multi-threading operations as well. In case if you have any doubts, feel free to ask in the comments. I would love to help. Otherwise, good day and thank you very much.